Okay, we're going to look at multiplying radicals here, the steps for that. So it's distribute it into the parentheses if you need it. Step 2, multiply the numbers outside the radical, and then break the numbers inside the radical and put them under one radical. So basically what this is saying, so that you're not confused, it's just the same as simplifying. All you need to do is put outside with outside together through multiplication, and then inside with inside, and then do what you did in the previous video. I'm going to start us off, and again, please do this for all my square roots for me. And I keep forgetting to say this, but we always want to start off by putting the question into Desmos. Sometimes they're all perfect squares and we don't have to do any work. So this says the product. Okay, so let's talk about this key word. This word here means multiply. Okay, so the product of these two numbers means the multiplication of these two radicals. Numbers, radicals. Boom. All right, so it's not a whole number, so I do have to do some work. There's nothing different from the previous video. The new thing that you just have to keep track of, it says outside with outside, inside with inside. So let's go ahead and do that. What are the numbers outside of your radical, outside of your house? 5 and 4. So you're going to put those together through multiplication. And I'm going to leave a little, well, actually I won't. Then you have inside with inside. So what are your numbers inside? You have 32 times 6. And that's the only new thing. After that, you just break it down like you did in the previous. Outside with outside, inside with inside. We're going to check this step by step because actually I forgot to show you in the previous videos. I mentioned it, I just didn't show you how. We're going to check every step to make sure that it makes sense. So again, do my numbers match? Yes. So me doing this has not changed the question. All right. So anytime you're multiplying radicals, again, outside with outside on the outside, inside with inside on the inside. All right. So let's go ahead and start breaking down 32 like we normally would. So if we broke down 32, 2 times 16. 2 is a prime number, so circle it. Break down 16. Again, you're going to check 2. 2 times 8. So 2 is a prime number, so circle it. Break down 8. And again, you see I'm just starting on new lines. All right, 8 breaks down to 2 times 4. Again, we're at 4 now. Break down 4. All right, so now I'm at prime numbers, so 2 times 2. Before I move on, I'm just going to check it. So I should have 1, 2, 3, 4, 5. 5, 2. So 2 times 2 times 2 times 2 times 2 should give me 32. It does. All right. So since it gives me 32, I'm going to get rid of these lines here because I'm going to need them. And I'm going to break down the next number, which is 6. So 6, I'm going to check my first prime, which is 2. That works. 2 times 3. Now, because both 2 and 3 are prime, I'm going to circle and we're done. Again, checking it with the calculator, 2 times 3 is 6, so I did that correctly. All right, so this is my breakdown. So we have 5 times 4, leave a space. And I really should have done this like vertically, but it's okay. Now I'm going to break down 32 to 5 2s. 1, 2, 3, 4, 5. And 6 breaks down to 1, 2, and a 3. And again, I just keep them in order. I'm going to put this in the calculator to make sure that I'm good. I have outside 5 times 4. Inside, I have 5 2s. 1, 2, 3, 4, 5. And then I have the 2 times 3. And again, what's happening? I'm still matching up, so I am good. Okay. Now what am I going to do? I'm going to take out books. All right. So what's my index? Invisible 2. So how many cards make a book? 2 cards make 1 book. Or if you're not doing it in my class, 2 numbers that look exactly alike, twins, when they go outside their house to everyone else, they look the same. So twins look like one person. So 2 cards make 1 book. Okay, so twins, I'm taking out my twins. The twins look the same to people outside. 2 cards make 1 book. And notice I'm doing this one at a time. Please do not try and do it all together. Just circle, cancel out, circle, cancel out, circle, cancel out. All right, so this is what I have now. We're going to double check that to make sure. So I'm going to do 2 cards. So I'm going to delete that. 2 cards make what? 1 book through multiplication. I'm still okay. 2 cards, right? 2 cards make what? 1 book. So I'm still okay because it's still matching. 2 cards, delete that, makes what? 1 book. So I'm still okay. So this is what I have outside. That's what I also have in the calculator. Well, I have no more books to take out, so all I have to do is simplify. So we're going to take this whole line, Control C, Control V. This is going to be 160, and I'm going to double check before I even write it down. Boom, I still match. So this is going to be 160 radical 3. All right, so this result is irrational. And again, why is it irrational? Look right here. It is not repeating. and it does not end. So even though Desmos ends at whatever, this is like 9 numbers, it still keeps going on forever. They just are not going to write a number forever. So it cannot be written as a ratio of two integers, and its decimal expansion does not terminate or repeat. Now we're going to learn how to multiply cube roots, and the process is exactly the same. So as I do example 2, you're going to do example 3. And it doesn't even matter that this is cube root and this is square root, because the question is asking how would you set it up. Find the area. So again, from 3rd grade, we know that the base times the height is the area. So how would I set it up? Exactly like that. The base, which in this case is cube root 625 n to the 5th power, times the height, which is cube root of 24, is how I'd find the area. So what kind of problem is this? Another way of saying the product. So I don't know how they're going to ask you. That's why we have multiple representations. So question is, how would you set yours up? So go ahead and set it up right there. All right, now that you've done that, how do I simplify? I'm doing the exact same thing I did before. Numbers outside multiplied together. There's 1 times 1, which is 1. And then inside multiplied together. So this is what I'm looking at now. I have an invisible 1 outside. Inside, I have 625 n to the 5th power times 24. Okay, now we're going to go ahead and simplify like we would if we were doing this in the previous video. 625 breaking down, and I already know that this is divisible by 5, but again, I'll just go with what I taught you. Check 2 doesn't work, check 3 doesn't work, check 5 it does work. Okay, so this is 5 times 125. Since 2 and 3 already didn't work, I'm not going to start with that. I'm going to start with what did work, which was 5, which works again. 5 times 25. Break down 25 again with 5, and that works to 5 times 5. And again, that brings me to the end. I am not going to get lazy. I'm going to check my prime factorization every time, because if I make a mistake, then it's going to mess up my whole problem. That does work. Put your question in the calculator. So we're going to go hit functions, go down to the bottom in the middle there. You're going to click that. You need it to be cube root, and we're going to do 625. Now, this does say n shift 6 to the 5th power, and you can see it's going to give you an error. So it says try adding y equals. All right, cube root, again, functions. Scroll all the way to the bottom, or you could have just copied the one you already have. And then you have 24. All right, so this is my original. This time I'm going to match it with the graph. So my graph should match with my answer. I'm going to copy this question down, Control C, Control V. I'm going to replace 625 with my prime factorization of 5 times 5 times 5 times 5. All right. Again, what's the problem? Try adding y equals. And if this is correct, my graphs will match. If this is, yes, my graphs matched exactly. See, purple went over. Yup. That's what I'm talking about. Okay, so we're going to stick doing this in the calculator. That way we're checking to make sure we're okay. Now we're going to break down 24. So 24 divided by 2. 2 times 12. Okay, let's keep breaking down 12. So go to my next line. We're going to do 12 divided by 2 again. That works. 2 times 6. Break down 6. Go to the next line. 6 divided by 2 is 2 times 3. Since they're both prime, we can go ahead and circle both. We're going to check it right here, like a mini check. 2 times 2 times 2 times 3. Does that work? Yes, that's 24. So I'm going to copy this, Control C, and I'm going to come right here. Oops, undo. Come here where the 24 is, delete the 24 and put in my new thing. Did my graph still overlap? Yes. So we are good. Okay. All right. So now we're putting these under the same radical. So I'm just going to copy this, right? Delete that. I don't even know why I put it under a different radical to begin with. Hey, oh, not there. Delete that. Right arrow down and then paste that there. And it needs to be a multiplication sign. So again, are we still matching? Yes, we are. We are in good shape. So that's what this is. So I'm going to write this out on paper, cube roots, and in order. So I'm going to put these in order. Okay, so we have 2, 2, 2, 3, 2, 2, 2, 3, then 4 fives, 1, 2, 3, 4 fives. And then how do I break down n to the 5th power? That's n times n times n times n times n, 5 times. So over here, times 1, 2, 3, 4, 5. Do not be lazy to do this step. It's really going to help you at the very end. All right, so now making books. Okay, how many cards make a book? I'm going to delete this real quick. All right. Now, I don't know if it'll work here, but let's see. Let's see. All right. So 3 cards or triplets make 1 book. So here are my triplets, or 3 cards make 1 book. When my triplets go outside, people confuse them for the same person. All right. Another 3 cards right here. I've got a triplet of 5. 3 cards make 1 book. Okay. Then I don't have triplets of 5 anymore. I got triplets of N. 3 cards make 1 book. Any other triplets? Nope. All right. So now that I'm done, I'm going to put that in the calculator and see if it matches. So this is 2 times 5 times N. And then I took out a triplet of 5, right? A triplet of 2. And see, something is wrong. Why? Because I haven't taken my triplet of N's out. So let's write N times N times N times N times N. So I need my triplets of N. Boom. And now we're back to matching. All right, we're back to matching. Okay, now it looks like my paper, it looks like the calculator, and we're good. All right, I can't take out any more triplets, so now it's about combining. So 2 times 5 is 10. Control C, Control V. So this is going to be 10. And cube root, and make sure that 3 is really small, that index. So this is going to be 10. Let's see if it changes anything. 10n, I'm still okay, I'm still matching. Then what can combine here? 5 times 3, which is 15. All right, so that's going to be 15. Again, let's double check that. So take that out. Take that out. And we're going to do 15 times. Okay, so you saw it mismatched for a second, right? But then when I put it back in, we were good. All right, so I have 15n. How do I simplify n times n? That's like me writing n squared. So this is like n shift 6 to the power of 2. And again, you see, I wasn't matching for a second. And as soon as I put that in, I was back to matching. So this is n squared. So when we have variables, we can still check it with a calculator to make sure the graph matches exactly. I have some applied questions for you. What that means is questions that I haven't explicitly taught, but I want you to be able to figure it out. So I'm going to start you off on my applied questions, and then we're going to see if you can finish it off. It says, what would you need to multiply radical 32 by to get this? So what it's saying is radical 32 times something is going to give you this. And the hint is start breaking everything down and then see what's missing here to get you this answer. All right, so go ahead and give that a shot. Now, because I cannot do every single question that anyone will ever ask you, I want you to think about how to do this one. It says, find the area of the entire image, the large rectangle, that's this large one right here, that's 50 feet squared, and the smallest squares, these green ones right here, they're 2 feet squared each. Can you find me the area of the entire image? Just think about it for a second. If you get stuck, I'll definitely help you. But remember, one of the things that I want to teach you in this class is how to think. So go ahead and give that a good try. Let's practice.